Welcome back, everyone, to another year and more videos, more hi-fi adventures. So this is the first one for the year. The Luxman will be back. We've still got more to do on that. The LV105U. I'm just waiting on some parts still. So yeah, that's on the back burner for a little bit. But I managed to score this off Marketplace, a tube amp. Ooh, tubes. Yeah, I'm not an expert on tubes. I'm not really an expert on anything, to be honest, but tubes are really out of my league a lot of the time. But I think we can muddle our way through some stuff on some units like this. So this is quite the beast. It is 2 by roughly 20 watts a channel. It has 12 AX7 tubes. I'm just looking at the thing now. 6 BQ5 tubes. Solid state rectifier, though not very good. It's got a fully featured tone section. It's got treble bass, scratch filter, rumble filter, loudness. It's got motional feedback, whatever the hell that is. Variable dampening. Channel switching, so you can reverse the channels, you can do all sorts of things. And it's got this cool little meter which allows you to balance the left and right channel signals because they tend to float a little bit with tubes and one can be weaker than the other, which is quite a nice thing. And it has a full phono preamp as well for turntables. It's quite a nice unit. I like it. It's made in Japan. 1966. It's actually sort of the end of the tube era, so this is probably as mature as tubes get, I would say. Now, got these quite big output transformers, a choke here, power transformer, a lot of tubes going on here. They're all original. Nothing's been touched in this unit yet, which could be a good thing or a bad thing. I'm not sure yet. But we need to do some work on this thing. It does run. It's got a bit of a buzz, bit of a hum. Not nothing crazy, but we need to do a few things. And I know some people have commented on videos, you should leave it all original. No, I'm not leaving it all original. I want it to last. I don't want it to blow up on me. And I also don't want it to blow up whatever I've got it plugged into. So, yeah, we are not doing a ground up restoration on this, but we're going to be changing some parts at least. So what are we doing? Well, we're changing these filter caps. We're changing these caps as well. These are dual caps, so there's like 2 caps in one. So they're going to be a little bit problematic. We're going to be fitting these ones for those and leaving them in, most likely, just for cosmetics. And we'll probably figure out some way to mount these underneath. The main filter caps are hilarious. These are the replacements. They are over twice the voltage of the old ones and almost twice the capacity. And they're still half the size. This is pretty funny. Yeah, capacitor technology is just crazy. Now, some interesting things. I'll put in some video here. These caps are 180 volt rated. Now, the voltages I was testing on these was 190 volts. So I don't know if they spec'd these really, really wrong, or the power supply is just way hotter than it was in 1960, which is quite possible as well. But that is something we have to deal with, and this is what I'm referring to. Like, these caps are not only really old, almost, 60 years old-ish, they're also under spec. So yeah, over way too much voltage going into them. So they've got to be changed. There's a couple of, I'll flip this up quickly. There are some diodes here and here. They are really old types of diodes. And I did some testing just briefly before we did this video, so I don't look like a complete idiot. I was seeing if I could get away with using a full bridge rectifier with 4 diodes instead of this weird center tap deal, whatever they're doing here. And we can. So the voltages were within like 5 volts, and that was unloaded on one of them. So I think the voltages are going to work out basically identical. So we're getting rid of these diodes, putting in a full bridge rectifier, nice new efficient one that hopefully is a bit quieter, not so much noise. We're changing these filter caps, and I don't know what this does, by the way. I know it's a sort of a variable power resistor, but yeah, the schematic is not super clear. We've got to change these double caps. And what else are we doing? Well, I was just playing around. This balance pot is faulty. It has a broken connection on it. So we've got to try and salvage that because it is a 2-in-1 pot that's sort of reversed. So it's logarithmic and then reversed logarithmic, which is really problematic to try and replace. So yeah, this is, I don't know what sort of a video this is going to be, but I thought we'd just go at it and see what we end up with. I hope you enjoy the video. We don't get to do tubes very often. Well, full tubes anyway. So let's get these caps ripped out first, I think, and then we'll work on the rectifier as well. Let's get started. All right, so I've been having a think, desoldered this old capacitor, and we're going to put on some solder tabs. I'm going to break off the bottom, and they're going to be soldered directly onto the capacitor so we can fit some new ones. Now, I'm going to join all the original terminals on this capacitor together and just create like a common ground type setup. And then we'll put the capacitors mounted on here and soldered together. Now, this is ground coupled, so it's not floating, so I could just ground it to the chassis, but I'm a little bit worried about grounding loops. So I'm going to keep it as close to original as possible, but shorting the original legs of this capacitor together, just so it's no charge, it's not playing a part in the circuit anymore, but we'll be using it for the mounting points regardless. So let's see what we can do. Alrighty, we're all done. This was a bit more work than I was hoping, but anyway, we made it. So the primary filter caps are changed out. The double caps have been disconnected and replaced with this monstrosity, which I'm not completely happy with, but is what it is. So the full bridge rectifier is installed. The two diodes that were from the 1960s are gone. So yeah, full bridge rectifier, new wiring straight into these caps. It does have a sort of a voltage doubler circuit which takes the 190 volts off this and brings it to 380 volts DC. I don't fully understand how it works, but I was able to recreate it. So there's that. And the voltages are exactly where they were before, which is brilliant because I was a little bit worried the voltages might creep with the new efficiency or high efficiency diodes in the full bridge, but we're all good. So these double caps are a monstrosity, but they work. So there's like a terminal strip, two caps on each. Yeah, so they're really solid. That one's maybe not as solid, but it ain't going anywhere. This one is not budging. I had to add this bridge wire for the ground, and that's just for stability more than anything. It doesn't need to be that big or anything, but it just helps hold the caps together at the base. These resistors were relocated, so we're all good there. So that I had to sort of come up with something a little bit inventive to get these off and floating because they are decent. They look like a decent wattage, so just got to make sure they can breathe. These resistors, I had to sort of trim the end, put a wire on, and extend them to their new locations, which is all fine. We also have this adjustable resistor here, which seems to be for the heater voltage. Heater voltage is perfect, so this has been relocated, and I didn't really need to touch it, so we've left that alone. Changed the fuel electrolytics here. Added one in here, and there's also one down here as well for this bias resistor. These are adjustable. This one I thought was standard, but it's not. It looks like what happened. I was trying to nut out what exactly happened, but there was some corrosion on this metal plate, which happens to pretty much line up with where that resistor was. So I have a feeling it got wet and rusted, and then it shorted out, and hoping it didn't damage anything else, but it does work, so we'll leave it at that. I don't know when this was done. It could have been done decades ago. They don't look new. They look like an older style ceramic resistor. But anyway, this cap was missing from the repair. I added it back in, and that's a cathode resistor bypass capacitor, I believe. This one's a smaller one, but there's only about 20 volts across the caps. So that one's way over spec, but I didn't have any more 35 volt caps, so they're the same. But yeah, anyway, I'm waffling on. These capacitors here, I didn't realize are actually paper capacitors, wax coated. Never really seen them before. I took one out of circuit. It seems to test okay, but I don't have an ESR meter that can read this low. So I may change these in a future thing. Now, the balance pot. This was a pain in the butt. Attempted a repair. The repair was successful as far as I can tell. The resistance and everything checks out, but it's just not right. It's all scratchy and it's popping and doing all sorts of weird things. So this is a 1 meg ohm trim pot. One side's logarithmic, but the other side is a reverse logarithmic, which is just weird, really weird. I don't have anything like this, and you're not going to be able to find anything like this these days. These things were bespoke for their application. I took a 250K a dual gang pot, logarithmic. It's not reversed or anything. It's just standard, same on both gangs, and it works. I can balance it. So I don't know if it has other implications in the circuit, but I'm going to just leave it. So yeah, I really wanted to fix this. I didn't want to do anything to it, but this is just going away. It works, it balances, but the balance is quite far to the right now, but it's within range, and that's good enough for me. And yeah, so it's all back in, and we're going to leave it at that. Bit of top action for you. Look at those tubes. God, they look absolutely amazing. They make a great heater for your house as well. Not efficient whatsoever. Very nice. And those big output transformers, they are massive. Yeah, so we got the new filter caps in. They are hilariously small. They don't even get like halfway in the chassis to the top of it. Got the original double caps still in here. They're just for aesthetics though. Got the new caps underneath. Yeah, so I haven't put the knob back on the balance pot yet, so I'll do that later. Just doing a bit of testing at the moment. It's running great. Testing it through my Stax L700s, electrostatic ear speakers, on the 4 ohm tap running off this unit. So if these can't hear any noise or hum or whatever, speakers got no chance. These things are so sensitive to whatever you feed them. So I've got the 4 ohm taps running into this SRD. We're going to be doing a video on electrostatics and some custom stuff very soon, so stay tuned for that. This sounds amazing. This MFB circuit is actually really handy for stacks because you can increase the bass going to them without any equalizer or anything, and it's exactly what these need to just drive up the low end because they need more grunts. But have a listen. Yeah, just amazing stuff. Anyway, hope you enjoyed this slightly chaotic video. Stay tuned, we've got a new one coming up with stacks, and that's going to be a real fun adventure, multiple parts, and the Luxman work log is going to be done soon, so don't worry about it. We'll get back to that. Hope you enjoyed the video. We will see you in the next one.